Hello guys, and welcome back to a new video. In this video, we're going to be discussing optimization in calculus. I actually have a friend here today. His name is Callan.
Hi, I'm Callan. That's not my real name though. I'm glad to be here on this long distance call with Come Calculate today.
Great. Today we will be doing optimization. You may be wondering, what is optimization? Well, optimization is a form of math that is the action of making the best or most effective use of a situation or resource. Basically, optimization is finding the best use for something in a certain situation. For example, the maximum amount of area enclosed for a limited amount of fencing available.
Our first question for today is, a rectangular yard is to enclose an area of 200 square meters. Fencing is required on only 3 sides, since one side will lie on the wall of a building. The length and width of the yard are each required to measure at least 5 meters. What dimensions will minimize the total fencing required, and what will be the minimum fencing?
To work out this optimization question, we must first draw up a simple diagram. This will be our diagram. So we'll have our building here, and then our paddock here. So we'll call this side here Y, and we'll call this side here X. So that means that the equation for the perimeter is 2y plus x.
Great, now we know the perimeter. We also know the required area, so we can write this as area equals x times y.
Okay. We are going to rewrite this area equals x times y and change it to 200 equals x times y. The reason it is like this is because we are going to use this as our constraint. Constraint is the equation out of the perimeter and the area that has a set value.
The opposite, an objective equation, has to be worked out with help from the constraint. We have the constraint so we can work out the objective. We just need to isolate either x or y in this case.
We're going to use the constraint to isolate a value. In the constraint equation, you can see we have 200 equals x times y. If we want to isolate a variable, we need to divide by either x or y. We have to divide a variable that is being multiplied.
We're going to divide by x, and this gives us 200 divided by x equals y. Perfect. Now we add that to our objective equation, and the objective equation is going to become perimeter equals 2 times 200 divided by x plus x. This is what we want to work out.
Right. We're going to multiply 2, which is 2 over 1, as a fraction by 200 over x. This gives us 400 over x, as 2 times 200 equals 400, and 1 times x equals x. Okay, we are very close to finding the derivative of the equation. We must move the x in 400 to the top. The way we do this is we turn 400 over x into 400x to the power of -1. Great. Then we find the derivative. The derivative rule is x to the power of n is n times xn minus 1. So we are going to do this for this and the x. Great. So just clean this up. So this is going to become -1 times 400x to the power of -2 plus 1. Great. So now we are going to set this to 0.
We can simplify this to negative 400x to the negative second plus 1 equals 0. Now we will add 400x to the negative second to both sides. This makes it into 1 equals 400x to the negative second. Knowing this is very good. It means that we just turn the 400x to the negative second into 400 over x squared. We know this because we turn 400 over x to 400x to the negative 1. So the x becomes x squared. With this equation, we can just multiply by x squared.
This means that the equation 400 equals x to the power of 2. Now if we find the square root of, so that looks like this, 400 over x squared, and then if we just multiply it, it becomes like this, 400 equals x squared. Great, so now we want to get this as just x, so we're going to put it to the square root, so square root of x squared is x, so 400. Now, if we plug that into our calculators, we are going to get square root of 400 equals 20. So we know that x equals 20. Great. Then if we go back to our constraint equation, we have the equation 200 over x equals y. So that means that 200 over 20 equals y. Okay, this is good. So 200 divided by 20 is 10. So y equals 10. Great. Now we know the dimensions for the minimum fencing. They are 20 by 10.
The answer to question B would be the perimeter equation or the objective equation with x and y plugged in. So it would look something like this. P equals 2 times 10 plus 20. So if we evaluate this, the perimeter would be 20 plus 20, which is 40. Therefore, the answer to question B is 40. All right, on to our next question. Our next question is this. A farmer has only 1,600 meters of fencing to enclose a rectangular area which will be divided into 3 pens. The 2 lines dividing the area must be shown vertically. What is the maximum total area of the 3 pens that he can enclose with the limited fencing? Wait, hang on, the answer's there. It's fine. I'll start again. Our next question is, a farmer has only 1,600 meters of fencing to enclose a rectangular area which will be divided into 3 pens. The 2 lines dividing the area must be shown vertically. What is the maximum total area of the 3 pens that he can enclose with the limited fencing? Okay, now let's draw a diagram. So, this is the pen. And then it will be split into 3 pens. So this is the yard with 3 pens. So now
there is X, X, Y, 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 Y. So that is going to be our perimeter.
This means that the total fencing required will be 2x plus 4y. Because the total fencing required is 1,600 meters, this means that 2x plus 4y equals to 1,600. The total area will be x times y.
Great. Now we must relate the two variables like this. 2x equals 1,600 minus 4y. Great. So we can divide this or simplify this to x equals 800 minus 2y. This is if we divide this by 2.
Now, let's substitute. So, we'll take the total area equation, and instead of x, we'll substitute it with y. So then we have 800 minus 2y multiplied by y.
Okay. Now we are going to simplify this to 800y minus 2y squared. Now we're going to take the derivative. So this derivative is going to be 800 minus 4y. Then we'll set this to 0. Okay, great. Now we solve. So if we subtract 800 from both sides, we get negative 4y equals negative 800.
And finally, we divide both sides by negative 4. This turns into y equals 200. We find the corresponding x looking back at x equals 800 minus 2y, and we get this, which means x equals 800 minus 400. So x equals 400. Now we have found a point where it is either the minimum or the maximum. To find out whether it is a minimum or a maximum, we can use the second derivative test.
To use this, we take the derivative of the derivative. So the derivative of 800 minus 4y. So this is going to become, if we put this to the derivative, it will become, so the derivative of a constant like 800 is going to be 0 minus and then 4. So this second derivative is going to be equal to negative 4. Because this is a negative number, it means that it is a maximum.
Nice. Now that we know it is a maximum, we will use the variables x and y to find the total area. As shown above, the total area is x times y. So the total area will be 200 times 400. So the answer to this problem is If we put this into a calculator, 200 times 400 is 80,000.